We're going to be solving Leetcode 2830, maximize the profit as a salesman. It's part of the weekly contest 359. So in this question, we're given an integer n that represents the number of houses on a number line numbered from 0 through n minus 1. Additionally, we're given a 2D integer array offers where each element in offers represents an offer, which has three components, the start I, end I, and gold I, which represents the ith offer, what the ith buyer wants to buy. The ith buyer wants to buy all houses from start I through end I, both inclusive, for gold I amount of gold. And we are the salesman. We are a salesman. Our goal is to maximize our earnings by strategically selecting and selling houses to these buyers, right? So we've got to return the maximum amount of gold that we can earn. Know that different buyers cannot buy the same house, of course, and some houses may remain unsold, right? So essentially, we're given a range, a list of intervals, and each interval has some value. We've got to select the best set of non-overlapping intervals such that the sum of values of each of these interval is maximized, is the maximum possible among the original list, right? So let's look at some examples. In the first example, we're given 5 houses, and we're given these 3 offers. As you can see, the first offer is for house 0 for a value of 1. The second offer is for houses 0 through 2 for total value of 2. And for 1 through 3 for total value of 2, right? The 0 through 0 is overlapping with 0 through 2, so we cannot select both of them. Similarly, 0, 2 is intersecting with 1, 3. So we cannot select both of them either, right? But 0, 0 is non-overlapping with 1, 3. So we can select 0, 0 and 1, 3. So if we select these two, we're going to be making total of 3 golds, right? If we select just this one, and since we cannot select other two because they intersect with this one, we can only make 2. So therefore, we should select the first and the third offer to make total 3 gold coins. And that's what the answer is, right, for this case. In example 2, we have the same intervals, but the value of each interval has changed. Now the value of the this interval is now 10, sorry. So then we can just select this one and make 10 golds. And of course, you cannot select the other two because they were intersecting with this one. And their sum is like, if you were to select just these two, the sum would be 3, which is less than 10. So therefore, we should just select this one, right? So now the problem is clear. Let's see the constraints. N is 10 to the 5, which is the number of houses 10 to the 5. And offers is, of course, of size 10 to the 5 again. So this strongly suggests that we need to come up with an order n or an n log n approach because n squared would be 10 to the 10, which is definitely not runnable, right? All right, so what are some initial thoughts that we can throw at this problem? So one of the ideas that we can see here is the following, right? The hints here are, okay, you got to maximize some objective, right? So whenever you see a problem that asks to maximize, minimize, or count, sometimes it's count the number of ways, then DP is obviously one of the candidates for attempting to solve that problem, right? This is just from my experience. And one other thing that you can see here is that there is a sort of a characterization in which you can see that this is that there is a set of overlapping subproblems in this question, right? How is there overlapping subproblems in this question? So think about picking up any interval, right? Let's say you're considering picking up this interval and seeing what are all the options that you can, what are all the other intervals that you can pick if you were to necessarily pick this interval, right? The set of future intervals that you can pick, therefore, is constrained by your previous choices, right? Because you cannot pick any other interval. If you have picked this one, you cannot pick any other interval that intersects with this one, right? So now you have to repeat the problem. Once you have picked this, you have to repeat the problem on a smaller set of available intervals. And that's why it's an overlapping subproblem, because your future choice depends on your previous choice. And the future choice can arise in different ways depending on different previous choices, right? So therefore, the space is constantly overlapping and it's a subproblem, and you can just employ the same logic at this subproblem. So that gives the hint of a DP recurrence in this problem context, right? So together with the maximization objective and this DP recurrence subproblem idea, we can just attempt a DP solution and see if we can come up with something, come up with a DP recurrence that would solve this problem, right? So that's a good starting point. One more thing we can think of here is that all the intervals, they are given to us in a random order. So, and there's no need to maintain any ordering on these intervals because end of the day, we just got to pick some of them, and their ordering relative ordering doesn't matter. So it makes sense to just sort them all, right? So this is kind of like a mirror check that I do before I solve any problem. If the array or the vector in this case, if it can be sorted without affecting the outcome of the problem, then you should consider sorting it and seeing if there's some value that you can get out of sorting it. And it's, of course, it's going to be order n log n, so it's obviously sortable. uh, it's obviously, I mean, runnable. So let's just sort it. Let's just sort the offers, right? And then see if we can come up with a DP recurrence, right? So I'm defining M to be the size of the offers, right? And just sort them, right? And now let's come up with a DP recurrence, right? So let's think about this. Right? Let's define M of I to be the max profit that can be earned if we were to necessarily select offer I, right? Necessarily select max profit can be earned from offers I through m minus 1, both inclusive, if we were to necessarily pick offer I, right? And then, so let's just consider this DP recurrence, right? I'm just starting out with some recurrence and seeing if it can work, right? And then if we could come up with this recurrence, then the answer would just be max over all of such mi's over all I, right? This would be the answer, right? So let's write the repeat recurrence. Let's see how it can be constructed. So of course you got to pick up offer I, right? So whatever profit you can, let me call it profit. So whatever profit you can get by selecting offer I, right? And then you got to pick up, you got to find out what's the answer for picking up the next offer, which is the first, which is the jth offer, and j being on the right side of I, right? So every jth interval on the right side of I, right, that doesn't intersect with I, if you can pick that one, right, then the answer would just be the max of the problem, of the same problem, from picking up every such j on its side that doesn't intersect with I, right? And then you just take the max over all these mj's, right? So let me just write this down. Max of mj for all j greater than I, such that offer j does not intersect with offer I, right? So yeah, right? So what would be the time complexity for this DP recurrence? Of course, this is gonna work, right? So now the only question is, will this work within n, in under n squared, right? We needed to run in order n log n or order n. So let's see. So for every I, if we're gonna get the max profit, then we gotta find out all such eligible values of j on the right side of I, and then we gotta take the max over all of them. So this is gonna be a linear search. We're gonna have to run over all the values of m, all the values of eligible j's on m, right? So it's gonna be order m, and then we gotta in the outer loop we gotta run we gotta compute or m over all I in range m, right? So together it becomes order m squared, right? So this approach is order m squared, right? And m is the size of offers, and offer size is 10 to the 5. So m squared is 10 to the 10, which is not runnable. So we got to come up with an optimization here to make it work, right? So what can we do here, right, to optimize this DP approach? Right? So so one fact to note here is that as soon as you find the first j on its right, right? Like what's the first j that's eligible here? The first j that's eligible here, you can find it using a binary search, right? You can just, because since the offers have been sorted, we can just find the first non-overlapping j on the right side of I using binary search on offers, right? And then once you find the first such j, you know that every interval on or after that first non-overlapping interval is an eligible candidate for this computation, right? So therefore, this implies that if you were to store, if you could have stored the max value, max over all m's, over all the j's on or after the first non-overlapping j, right? If you could have pre-computed this, right, value, you could have just accessed that value in order 1, right? Because all value on or after the first non-overlapping j is an eligible candidate for this max computation, right? So that implies, so then you could have just searched for j in log m and then just access the max value in order 1, right? So together it would become order m log m. So let me write down what I'm saying, right? So that it makes sense, right? Let me write down the intuitions, right? So once you've found out the first non-overlapping interval on I is right, every interval, let's call this j, right? Every interval in the range j through m minus 1 is an eligible next interval, right? So therefore, if we were to define a max values array, right? So let's say max values I is defined as max over mi, right, m of I plus 1, right, over m of m minus 1, right? If we were defining this max values array, right, and storing all the max values, then my DP recurrence could be rewritten as follows, right? We could just write max m of I as profit of I, right, plus max over mj, right? So then this becomes max values j, right, for the first j, for j greater than I, such that j is the first non-overlapping interval after I, right? And then we can just update max values by just taking the max values of I plus 1, right, and m of I, right? This is how we'll update the max values array as well, right? So yeah, so then this would make the need for iterating over, doing a linear search over all such j's redundant. We can just store the values, and then we can just search for j in log m, and overall the recurrence becomes order m log m for computing every such m, right? So the optimized DP is order m log m, right? Nice. So let's begin the implementation. Let's see how we're going to implement this. Right. So first, let's write down. So I'm going to be writing down a bottom-up DP, since that's come so naturally on this problem. Based on the description so far, right? It comes very naturally. You just need to go from right to left, right? Right. So let's do the base case. The base case is, of course, it's just going to be, you can just pick the last offer, right? So the base case value is just this, right? Of course, I got to define the memo array, which I haven't defined. M of size m, let's define the default value to be -1, and the last value is of course this. And we also got to define the max values array to store the max values over all m. So max values of course m, and let's call it -1, and max values is also gonna be just m of m minus 1, right? Right. And then of course we got to store the global max, right? So what's the global max, so that we can return the answer as max over all I, right? Max over all of mi, right? So the global max can be just initialized to the last value, right, for now, and then we can just keep taking global max over this. Right, now let's write the bottom up DP. So for int I ranging from m minus 2, since I already computed m minus 1, all the way through to 0, right, the first offer, right, we can just compute m of I using the DP recurrence that we defined here, right? It's gonna be the max of, we're gonna be profit of I, right? Let's call it offers I2, right? And we got to find out the first non-intersecting, right? So get first non-overlapping interval after on the right, on right, for I in offers, right? Not the best name, but you get the idea, right? So we get the first interval j, and let's say if j is not equal to -1, then m of I, because if there's no such non-overlapping interval to the right, then this method should return -1, right? And we can only add a value on its right if there's something non-zero there, right? So m1 must be plus equal to uh, max values over j, right? I'm just implementing this recurrence, right? And of course, you got to update max value also. So max values will just become max values of I will just become max of max values I plus 1 and m of I, right? And of course, we got to check whether global max is updated or not. So global max will just become max of global max and max values I. Oh, sorry, m of I. Actually, max values is going to store the max over all, right? So we don't even need to store global max. We can just max values of 0 will be our answer, right? Because we're going to store the max over all m's. So we don't even need, right? All right. So all that remains is to implement the binary search to find out the first j after I, right? So let's write down that method, int I, and of course we're accepting offers which are sorted, which have been sorted in increasing order, right? Uh, so let's just do lower bound and figure out what's the first offer. So let's call this, let me define an alias called current offer, which is just to make it cleaner, which is offers I, right? So what's the first offer in offers that is to the right side of current offer, right? So offers dot begin, offers dot end, and of course you got to supply a vector here. It's gonna be current offers ending, right? What's the ending? And I want int max because I want the first non-overlapping, right? So I'll supply the ending time, the end point of the current interval that I want to, the ith interval, right? And so then what this will return is the first offer on the right side of the current offer, on the right side of the current offer's ending, right? Because this has been specified as the first value. So this will return to me the first non-overlapping interval, right? But only if it already did not reach the end of the interval, right? So if it later, let's say if this reached the end, then it couldn't find a non-overlapping interval on the right, so it should return -1, right? But otherwise it found something, so it should return the index. So let me typecast it into integer and return the index, right? Right, so this should return the index. Right, let's see if this runs. A wrong answer. Okay, I return -1. Current offer int max. Okay, mi auto j, mi not -1, and m of I. Right, I didn't update max values, right? So max values also needs to be updated. So max values of I will just be max over max values of I plus 1 and m of I, right? I missed to do this update, this one. So yeah, let's run this now. Right, let's submit this and see. All right, it got accepted and it beats a lot of users, right? So yeah, so we came up with an m log m approach, and the learning in this question is, of course, right? So if you can come up with the intuition that okay, you can employ DP here, right? And then you can sort this, right? So if we hadn't sorted this, then we couldn't have employed this, right? Because the recurrence relation asks us to get it wants us to find out all the intervals that do not intersect with I, right? So if there's no ordering, then you couldn't have employed binary search to figure out what's the optimal interval on the right that should be picked up, right? So binary search allows us to so binary search can only be employed if you have like this, if you had this array, if you had the offers vector sorted. So that's why sorting was necessary. But even as a general rule, if you don't see a problem with sorting, you should consider sorting the array or the vector and seeing if that influences the outcome of your problem for solution. Right. So we came up with a DP recurrence, and then we realized there's an inefficiency there, and you can just throw storage. You can just store the answer, just memoize it, and that will just help you compute this in order one. And so then all that remains is finding out the optimal j in log m using binary search, and it helps bring it down everything to order m log m. All right. Hope you learned something. See you for the next problem.